Hello, you're welcome to my YouTube channel. Thank you for stopping by. Today we are looking at question number 17. Please note this is one of the videos in the series of videos where I go through exam style non-calculator questions. All right, so this particular question is checking our knowledge of similar shapes, as it is stated here, mathematically similar. So let's get right into it. Have you subscribed yet? Please do. And please ensure you watch the other videos. We have solved 16 questions so far, and this is question number 17. And we still have about 8 more questions to go after this. So please stick around. All right. Now, the triangle ABC is mathematically similar to triangle PQR. When we are told that two shapes are mathematically similar, it means that one is an enlargement of the other. That is, there's a scale factor linking the lengths of corresponding sides of each of the shapes. Now, this particular two shapes here, we need to identify the corresponding sides before we can even answer the questions. Taking a look at the angles, the way the angles have been shown, this angle here corresponds to this angle here. So this angle here corresponds to the angle Q. The angle at A corresponds to the angle at P, while the angle at B corresponds to the angle at Q. Therefore, line AB corresponds to line PQ. That is crucial. The area of triangle ABC is 15 centimeters square. So the area of this is 15 centimeters square. All right. We are now told to work out the area of triangle PQR. Since we've been told that these two shapes are mathematically similar, we need to find out the linear scale factor. That is, what is the relationship between the first one and the second one. Please observe that since the corresponding sides are PQ and AB, the linear scale factor will be given as 12 over 6, which gives us 2. Now, the area scale factor, because we are looking for the area of the larger one. So the area scale factor is the square of the linear scale factors. That will be 2 square, which is 4. So to find the area of the larger one, we need to multiply the area of the smaller one by the area scale factor. So we're going to have 15 times 4, which gives us 60. So the area of the larger triangle, that is triangle PQR, is going to be 60 centimeters. Please don't try to be finding the height of the triangle and so on. What is being tested here is your knowledge of similar shapes. And it is stated here that triangle ABC is mathematically similar to triangle PQR. Please bear that in mind. We're not done with this question yet. We're told in the B part that the triangles are the cross-section of prisms, which are also mathematically similar. It makes sense. Prisms are shapes that have uniform cross-section. So if their cross-sections are similar, then most likely the prisms made by these cross-sections will be similar. We are told that the volume of the smaller prism is 300 centimeters cubed. How do we find the volume of the prism again? Volume of prism, of any prism whatsoever, is given by area of cross-section times the height or the length, as the case might be. Okay, so if the volume of the smaller prism is that, so we can find the length of the smaller prism. Remember, we are looking for the length of the larger prism. So if we know the length of the smaller prism, we can apply our scale factor, our linear scale factor, to find the length of the larger prism. So to find length of smaller prism, length will be given by what? Volume over area. So the length of the smaller prism is the volume given as 300 divided by its area, which is 15, and that gives us 20 centimeters. Now, this is the length of the small one. The length of the large one will be the scale factor, which we worked out earlier as 2, times the length of the small one, which is what? 20, and that gives us 40. So the length of the larger prism will be 40 centimeters. Why did we just use 2? Remember, we know the length already, or we know the length of the smaller prism. We calculated the length of the smaller prism. So the relationship we're looking for now is length to length, and that is a linear thing. So that's why we are using the linear scale factor. We use the area scale factor here because we were looking for the area of the bigger triangle. I hope you understand that. Thank you for watching. Thank you for sticking around. We're going on to the very next one. Again, I ask, have you subscribed yet? Please subscribe and like the video. The next question will be on mensuration. We'll be talking about cylinders, cubes, and I think there's a sphere question down there. Yes, we'll be talking about cylinders, cubes, and spheres. See you in the next one. Bye.